Yeah, in this video about uh, one more previous year question, that is GATE 2020 from electromagnetic field theory only. See, in this question is given the information about the vector. So here f bar is a something is there, phi y minus k1 z into ax bar plus 3z plus k2 x k y bar plus a3y minus a4x into az bar. So, if this vector represents the conservative field, and where ax, ay, az are the unit vectors along the x, y, z and z axis, and is asked to calculate the values of constants k1, k2, k3. So, we know that any vector is said to be a conservative if its curl is equals to 0. That means here the given vector is f. So, if this vector is said to be a conservative field, f is said to be a conservative field, its curl must be is equals to 0. So, curl f bar is equals to, in order to satisfy this field, its curl must be equals to 0. That means curl f bar is equals to 0. We can write this curl f bar in another way, that in this way, that is del cross f bar is equals to 0. If your f bar satisfied this equation, then your vector is said to be a conservative field. Okay. So, now we will try to evaluate the values of k1, k2, k3 here, that is, so the curl of vector f is calculated like this, del cross f bar is equal to 0. So, the curl of any vector will be calculated in the determinant form, that is in this way, matrix determinant form. As given vector is in the Cartesian coordinate system, we need to take the first row elements are the unit vectors along the x comma y comma z axis, that is ax bar, ay bar and az bar, and second row elements are the operator del. Operator del is defined in Cartesian coordinate system. It will be like this, that is dou by dou x, a x bar plus dou by dou y, ay bar plus dou by dou z, az bar. This is the representation of operator del in the Cartesian coordinate system. Okay. So, now we need to write this the magnitudes of the del operator under this unit vectors, that means in the second row. Here we need to write the dou by dou x, and see here in the y direction we have the magnitude of dou by dou y, and here dou by dou z, and the given f bar is, how much it is given f bar is equals to, given f bar is equals to, for a minute, yes, that is phi y minus k1 z ax bar plus 3z plus k2x ay bar plus a3y minus 4x h bar. This was the given vector. So, as in the third row we need to write the magnitudes of the vector f. So, here we need to write phi y minus k1z, and here 3z plus k2x, and here k3y minus 4x. Now, calculate the determinant of this curl and equate it to 0. Now here Ax bar into, if you remove the first column, first row element, it will be like this, AD minus BC. Now here dou by dou y of, what is there, K3 y minus 4x and BC minus dou by dou z of 3z plus K2x. Okay, now minus ay bar, this one, first row, second column, first element. So now if we remove second column, first row element, then it will be dou by dou x of this one, K3 y minus 4x and minus one is the dou by dou z of 5y plus k1z, and third one az bar, first row, third column, then dou by dou x of this element, this two, like this, 3z plus k2x minus dou by dou y of 5y plus k1z. Now do the differentiation here, and it is equals to 0. So if we do the differentiation of this first term, Ax bar, here do the differentiation with respect to y, so that second term is equal to 0. X is constant, so differentiation of k3y with respect to y, which is equal to k3. Okay, sorry, first term is over. Next here we have the minus, and here k2x is in the components of x, but do the differentiation with respect to z, so this term is equal to 0. This differentiation of 3z with respect to z is 3. So now minus ay bar, this term, here this first term is going to be 0 as it is a constant, and second term is minus 4 into 1. Okay, and here there is a minus here, and do the differentiation with respect to the z. So first term is equal to 0, second term is equal to plus 1. Similarly do it for az bar. Here x z component is equal to 0, so k2 is left term, and minus dou by dou y of 5y, that means it is 5. The second term is anyway 0, which is equal to 0. So now compare this equation, left LHS is equal to RHS. So if you compare LHS is equal to RHS, then k3 minus is equal to 0, and minus 4 plus k1 is equal to, it is also 0, and k2 minus 5 is also equal to 0. So k3 is equal to 3, and k1 is equal to 4, and lastly k2 is equal to 5. Now the values of k1, k2, k3 are 4, 5, 3. Check the option 4, 5, 3. So 4, k1 value is 4, 5, 3, option B, and B is the correct. Thank you.